Okay, so welcome back. This is number 19 in our series. Can't believe it. And Machine Learning Easy, Unsupervised, and Supervised Learning. First of all, I want to call out my wonderful partner, host, sponsor, the IIBA of Tampa Bay. Again, if you're not a member, we'd love to have you join our group. The price is right. It's free. so please feel free to join us at meetup.com or on LinkedIn. You can find us on LinkedIn, IIBA Tampa Bay. You can find us on meetup.com. You can find us on Facebook. So hopefully, again, if you get a chance to join us, please do. This particular session is tied to the courses that I teach on business data analytics. Again, machine learning is a major component of where we're going as business analysts. I put together two courses. One is requirements development for business data analytics. One is project management for business data analytics. The requirements class is traditional requirements, with the exception of a focus predominantly on data as opposed to product and process, which are very important. And we do talk product and process in the course. However, I spend more time talking about data because obviously data is the new oil and it's the future, right? Actually, it's happening now. But the project management course is also a traditional project management course, however, geared towards business data analytics, the language of data. These color codes are associated with roles. If you read through this, if you print these two agendas out, they're designed to kind of work together. They look very similar. First would be the requirements, then would be a project management follow-up. If you go through this, you'll see it's traditional in the sense of the format: initiate, plan, execute, control, and close. Or if you're a developer, envision, plan, develop, stabilize, and deploy. However, if you look deeper into the agenda, you'll see that it's really specifically about data. This agenda comes from the cross-industry standard process for data mining and machine learning, which is kind of where I got a lot of the information, or some of the information that I'm going to speak to today. Quick background, I owned a software company in the 1990s, specialized in autonomous software robots, workflow automation, software integration, workflow automation. We called them Autobots. This particular section and all of these sessions, again, if you've never been, our goal here is to seek to understand and then train the trainer at the end. We hope that you'll pick something up in any one of these sessions. Everything's open source, and we ask that, if feel free to share it to anybody you want. If you need a PDF version of this, I can send that out to you. I'll talk about that at the end. These recordings will go up on our websites today. So if for some reason you'd like someone to come take a look at this, you can do that as well. This particular session is about machine learning at the easiest level. Okay, so I'm not pretending that I'm going to give you the end all be all on machine learning. I just want you to have a very quick way of understanding just kind of the basics that you need to know when you're sitting around talking to really anybody, and they bring up the word machine learning. So really, it boils down to unsupervised learning and supervised learning. I don't know if you were in, any of you were in the accounting course section, the one that I did on financial and managerial accounting, the numbers game. But I always talk about the fact that I had this great relationship with the first client who was a CFO, and she taught me that there were only two types of numbers. They either had a dollar sign or they didn't, which is a great piece of information that I've used for my entire career. As a matter of fact, both of my children, who are accountants, love it. To this day they use that. They talk about that to this day, that Dad always talked about. There's only two kinds of numbers. So for this section, I'm going to tell you that there's only two types of data. It's either unstructured or it's structured, which really goes very well with unsupervised and supervised. So you're going to find that the unsupervised machine learning is very much geared towards unstructured data, and the supervised learning is geared towards structured data. So again, that's just an easy way to remember these things. All right, so I saw this slide years ago and thought, wow, this is really powerful. Again, talking about just reporting and intelligence. And of course, you know, the word business intelligence has been around for many years, like 30 plus years. And when we look at this particular slide, you'll see that the first lower level items are business intelligence, which I thought was really interesting. So this is a pretty old slide, but standard reports, ad hoc reports, query, drill down, and alerts. A lot of this is about using historical data to predict future outcomes. Notice that the top is called business analytics. And again, I had this slide before the IIBA was even around as an institution. So this is a very old slide. And you'll see that it says, you know, business analytics, statistical analysis, forecasting, predictive modeling, optimization. The top, I guess, 3 tiers, forecasting, predictive modeling, and optimization, and in particular the top 2, is really where a lot of machine learning is occurring today. I mean, we're doing it at every level, don't misunderstand what I'm saying, but the mission, what's driving it, is the idea of predictive modeling, what will happen next, and optimization, what's the best thing that can happen. In the 1990s, a lot of large institutions who were grappling with data warehousing and all of the internet and the sheer growth of data as it was starting to really take off, got together and built kind of an informal cross-industry standard process for data mining, which is the fundamental structure that you need for machine learning. So if you're not set up for data mining, machine learning is not going to happen at your shop. So you have to go through this journey. And oh, I skipped the roles, but let me go back and just touch on them. You'll see where it says business understanding, data prep, modeling, evaluation, and deployment. Those are correlated to these images on the right. So the purple represents your business analyst, product owner. That would be understanding the business understanding. The yellow correlates to your Scrum Master, project manager, database administrator, and that would be data understanding. The 2 greens, which is really this session is really about these 2 green boxes, these 2 roles. The first is your IT system architect. That would be prepare your data. Below that, the other green box represents your developer, data scientist, subject matter expert. That would be model your data. Underneath that in blue is your QA tester. That would be, you know, stabilize. And then finally at the bottom is the blue intelligent assistant. In this case, it's Cortana with an orange box that represents deployment. So that's this evaluation. So that's where this correlates, this slide right here correlates to those roles. So again, business understanding, that's the purple, data understanding, that's the yellow, data prep and modeling, that's the 2 greens, evaluate would be the blue box, and deployment would be our intelligent assistant. So using past data to predict future outcomes, what's interesting about that is, again, it goes back to that original joke about IT, garbage in, garbage out. So if your data coming in isn't very good, then your predictions aren't going to be very good. So it's really important that the data that you are using be clean, and we call it clean and smooth. That was just a term that we used throughout my whole career. But some of the things that just generically that are done with machine learning, churn analysis, social network analysis, recommendation engines, locator tracking services, vision analytics, weather forecasting, discovery and document archiving, equipment monitoring, advertising analysis, pricing analysis, fraud detection, personalized insurance. These are solutions that are happening now. also within the industry, more specifically, things that are happening, for example, in manufacturing, predictive maintenance, warranty reserve estimation, propensity to buy, demand forecasting, process optimization, telematics. I won't read them all, but you can look at this slide and get a sense that there's a lot of work that's actually occurring right now as we speak. And these are things that are being done within these industries: manufacturing, retail, healthcare and life sciences, travel and hospitality, financial services, energy, feedstock, and utilities are all leveraging machine learning as we speak. So what do we really mean? Well, machine learning is really a process. It's really what it boils down to. And the first part is just get the data. So that's, where the data comes from. And we've shown previously through ETL, extract, transform, and load, that, first we got to get the data. The data comes from all kinds of different sources: log files, live feeds, internal systems producing data. I mean, it comes from everywhere. So that really is the domain of, kind of the relationship between the business analyst, the product owner / business analyst, the scrum master, project manager, database administrator, and the IT system architect, which then leads us to clean, prepare, and manipulate data, which again is a huge part of the process. And anybody that's in it, Cliff's online. Yeah, Cliff's online. This is Cliff's domain. Cliff's a data wrangler. We call those data wranglers. The people that do the bulk of the heavy lifting is getting everything clean and smooth. Once we get the data set up properly, then we can start to train the model. And that's kind of what we're going to be touching on today, is really 2 and 3. This, clean and prepare and train the model. And then finally, we get these models working, and then we test to validate and improve, after we've identified through deployment. Now, within the data science world and within the data wrangling world, there's this term called feature engineering. And feature engineering is a big component of what we're going to be doing as business analysts, communicating with our stakeholders and our IT system architects and our data scientists. This is a lot of where our requirements, actual written requirements, are going to come and be used. So the items that we document are going to show up here under this concept known as feature engineering. So this is, again, features. We're doing requirements, functional and feature-oriented requirements. This is kind of our domain. So we're going to be providing a lot of this kind of written documentation that then in turn going to abstract and write other requirements and build whatever it is that they need to. So let's talk a little bit about training. Just, what does it mean to actually train the model? So we talk about, and again, the easiest way to remember it is unstructured data, which is just kind of the vast majority of data. And we say unstructured, it doesn't mean that there's no structure. It just means that we have so many sources of data that haven't been brought together in a structured system like a SQL system. And the vast majority of data today resides in what they call data lakes. And we use something called NoSQL, not only SQL, which really is the kind of the beefiest thing out there to kind of manage all this. So you get all this data in, and the first thing that they try to do is make it more manageable. That's called dimensionality reduction. And then once they get it where it's manageable, then they go through this process of clustering. And then they kind of group things together. We're going to show you this in a second. Once you get it where it's manageable and kind of organized and clustered, then you can classify it. And then once you have it classified, which is under supervised learning with structured data, then you can begin to start doing regression, which is your prediction capability. Some of the tools, and again, I'm not an expert on any of these, so I don't pretend to be, but these are many of the algorithms that are used by our data scientists to do these things, clustering and dimensionality reduction under unsupervised, and then also unsupervised, you might have categorical. So these are continuous models, algorithms. You have categorical models, association analysis, you got, hidden Markov and all this kind of stuff. And again, I don't get into the level of detail for that. I don't need to. I'm a business analyst. While it's important that I know some of these terms, I'm not the subject matter expert on that. That's the data scientist. On the supervised side, you have classification, and a lot of different algorithms, KNN, trees, logistic regression, Bayes, SVM, and then on the supervised prediction, you've got regression, linear, polynomial, decision trees, random forests, things of that nature. So as a business analyst, I think it's important at least to have these terms, have heard them, and go look them up. I mean, if it's something that you're going to be working with quite a bit, it'd be useful to know in more detail what they're about. Here's another way of looking at this process. This was a really cool slide, this cheat sheet that I found. I thought this was really neat. And again, it gives you a starting point and shows you kind of the direction, how things might work, like through a flow, just to give you a sense of, oh, okay, this is sort of how the data scientist goes about deciding which algorithms that they're going to use. Okay, so again, I can send that out to you with the PDF if you're interested. Right, and again, you can always look at it here on the recording. What I want to do is just kind of walk you through conceptually the 4 concepts. So unsupervised learning, dimension reduction. So we get all this data, it comes in from all these different sources. And I don't know if any of you have ever opened up a log file and you've just seen like one field and it's just not even parsed out. It's all concatenated. And so there's like one giant field and all the data is in there and there's no delimiters. Okay. And you have tons of it and you go, hey, what do I do with this? First of all, you're trying to get it organized. So the first process is to try to figure out, how do I describe this with the fewest dimensions? That's called dimension reduction, which is, again, that just making it more manageable. Because when you're talking about zettabytes, which is kind of where we're going, of data, terabytes, zettabytes, just exabytes, zettabytes, just huge amounts of data. You need to get it where it's manageable, because again, these machines have to crunch all this data. Part of that process, so you dimension reduction, then you go in and it gets clustered into groups. So then okay, now we can see that there's some pattern recognition, that okay, this looks like that, this looks like that. Where this was really interesting was when they started training the machines to recognize photographs, and they started training the computer to go, that's a cat, that's a dog, that's a human, et cetera, et cetera. That's what this was doing. And I always find it interesting. So Cliff says, we had a fun project with something like this for Ironman. We taught the AI to recognize a participant's equipment from a picture. They always manually try to keep track of participants' equipment in the races via manually go over pictures. Over the course of months, we feed enough pictures and descriptions that it can now recognize and log a participant's equipment directly to the Ironman database for marketing. Wow, that's cool. So this is a cool, you'll see this exercise, this unsupervised learning, this clustering, this based on photographs. And I always love to search photographs on, my favorite is Bing. I'm a Bing image guy. And they always have, hey, this photograph, these are similar photographs. So I'm always looking at those similarities and just saying, oh, okay, how close are they? Is it really, what makes it similar? What makes it not similar? Just something to keep in mind. So when you're using a visual search, this is kind of what is being done in the background. Then we get to clustering. And this is my favorite slide because this is categories or classifications of beer. And I'm a stout drinker. So just FYI, in case we ever get to meet again, we will drink stout together, or I will drink stout and you can drink whatever you want. But someday I hope we get to meet together again. Anyway, so the idea is you get the data, you get it all kind of visually put together, and then the machine starts giving it it starts classifying it. And see, that's like what Cliff was saying, is that, hey, we can now give it descriptions. So it can now, go in and not only identify something, but it can actually add classification to that. And then that makes it easier to search and sort on. So now we've moved from unstructured data to structured. So unsupervised, unstructured, supervised, structured. The ultimate is once we get enough of this data and we've trained the machines very, very well, then we get to prediction. Regression is prediction. So you hear the word regression, but in your mind, I want you to think prediction, because that's really what they're talking about, is how do we predict the future? Well, again, we predict the future based on history. That's why accounting is so important. I can't stress that enough. We go through, and again, this isn't that class, but I always point out to people, if your accounting is not very good, if you're not accounting for the things that you're trying to predict, then your prediction's not going to work. So where's all this going? Well, I got good news and I got bad news. The good news, I'll give you the bad news. The bad news is your jobs are going to change. I don't know exactly how they're going to change, but they are going to change. The good news is we're still a little ways away from it, where it really changes. And if you're not familiar with the term the singularity, now you should learn it. This is, we're not far from the singularity, maybe 20 years. I don't know. The target was 2045, but they're not always on time. So we don't know if it's going to happen sooner or later, but this is artificial intelligence. So when you hear about artificial intelligence, that's really, and the singularity, that's really kind of the same thing. And it's the point at which the machines are much smarter than us humans. And what happens to us in our jobs and our future is beyond me. I have no idea. I can't. Some of it's dystopian sounding and some of it's really positive sounding. So again, I can only hope for the best. But this is where it's going. We're going to this, we're marching towards the singularity. So if you're not familiar with the singularity, after this session is over, I highly recommend that you go and look it up. and look up as much as you can about it. So that's, by the way, that's Ray Kurzweil, who's very famous for many, many things. So he's the founder of the Singularity University. He's also the founder of Life Extension, to where, people can live indefinitely. So that's Transcendence. That's that movie with Johnny Depp. That was based on the concepts of Ray Kurzweil. All right. So in summary, train the trainer. So hopefully some of this information was useful to you. So let me again go back to unstructured, unsupervised, structured, supervised. So unstructured data, dimension reduction, so we can manage it. Unstructured data, unsupervised learning, clustering, so we can kind of group it together. Once we get it to group together, then we can do supervised learning, which is classifying it. And then eventually supervised learning, which is regression, prediction, trying to predict the future. All right, are there any questions at all before we wrap it? Any questions, any thoughts? You guys all good? Everybody good?
Do you have an example of a project where you could kind of maybe walk through each one of those real quick? Maybe summarize or something. If it's too much, don't worry.
No, I mean, well, I could, yeah, let me think. Well, again, we can just use photographs as an example. The dimensionality reduction, the two things that were the hardest things to get going, like the very first thing that artificial intelligence people started working on. So first of all, the Artificial Intelligence Journal was founded in 1980. So that gives you an idea of how long ago they really started talking about this, 1980, which is what now, 40 years. And the first thing that they worked on historically was text, trying to get the machines to read. And the SAS, the SAS Institute, was one of the leaders, still is one of the leading institutions on machine learning, especially as it relates to understanding how the machines can read, and then going from there, and then language. So once they can read and they understand language, then it's voice, and then the ability for you to be able to talk to the machine, like with Alexa or Cortana or Siri, etc. So that was really the first goal, was trying to talk to the machines with your voice. Okay. Little side note about that. It turns out that one of the best and I don't know if you're familiar with the Rosetta Stone that's got the different languages on it that allowed the us to learn hieroglyphics. The stone that was found by Napoleon, et cetera, et cetera. Well, probably one of the greatest Rosetta Stones for language comes from Canada, because Canada has two languages, and yet it has the same laws. So the legal language and all of that had to be in French and in English. And I read this about, like, the Canadians worked very, very hard because when you translated, it had to be the same. So SAS Institute was able to leverage a lot of that information to help them develop the language components. We did that before, linguistics and morphology and all that. I went through that in a previous presentation. But that's kind of where a lot of this got started. Now, what happened is as the internet took off and storage became effectively free, we started storing photographs. And these photographs enabled the machine to then classify things. So you could say, okay, this is this and that's that, or whatever. One example that I like to show in a class is the machine. They train a computer to paint a Rembrandt painting. I don't know if you're familiar with Rembrandt, the painter, but he's my favorite painter. So I was really fascinated that they picked him of all people to paint. And they had the machine analyze all of his paintings. So they trained the computer to analyze every component of a Rembrandt painting, the eyes, the face, the mouths, the nose, the ears. And then what they did was they had the machine create its own Rembrandt, its own painting. And it's amazing because it literally looks like something Rembrandt would have painted. And they used a 3D printer to do it, because painting is actually three-dimensional. Anyway, long story short. But that was starting with dimensionality reduction, being able to look at things and then break them into pieces and then analyze what they're looking at, okay? Which kind of gets you this clustering, segmentation component. What you're gonna get in the real world, so those are just examples, but let's talk about the real world. In the real world, institutions get a lot of data. I don't know if you've seen raw data or just data in a field. Like I said, that's that's concatenated. It's not parsed. So there's no delimiter in the field. So you might get, you've probably seen this, where you open up Excel thinking you got this database table and it's column A and there's no delimiter. So it's just like huge amounts of data in that one column. So, we train the machine to go in and install delimiters to clean up this data so we can segment it into separate columns. Does that make sense, what I just said? Anybody?
Yes.
Yes? Okay, cool. So that's like one of the first things that we had to do in my company, was we used to get all this data, and it was like everything was in one field, and we had to go in and separate it into separate columns. Segment it. Then once it was segmented, then we could go and analyze it to classify it. We'd say, okay, these are these records, these are these records, these are these records. And then once it's classified, you can append to the data. You can add, categories of information, so you can do aggregation and summarization, which is really, that's kind of what we're doing, is we're taking data. Most of what we tend to do is we take data, raw data, we cluster it and segment it, and then we classify it. That's like the bulk of what a lot of work in database is just taking the data, segmenting it, and then classifying it. This dimensionality reduction is really tied to the fact that the volume of data is astronomical now. So it's just beyond the scope of what most people can even imagine in their heads. So there's got to be a way to make it easier to get to the most important components of the data. TensorFlow, I don't know if you're familiar with that. That's from Google. That's one of the tools that's very commonly used to do dimension reduction, and a lot of other things. But that's a big tool, because Google is, Google. One with 300 zeros behind it, right? One of the largest numbers that exists is a Google. I don't know if that, most people don't know that. Put a yes if you knew that Google was a number. Who knew that Google was actually a number? It's the name of a number, like a terabyte. So it's a 1 with 300 zeros behind it, is a Google. It was the largest named number that they could come up with. So look it up. Don't believe anything I say. I tell people all the time, don't believe anything, just look it up. Just look it up. Anyway, then the classification really is, like I said, for those of us in the business, segmenting, you get the data, you segment it, then you classify it. And that's that's data wrangling. We do a lot of that. Once you get the data clean and smooth, where everything's kind of working good, there's no errors, there's no omissions, you feel like your data table, your data set is really good, then management can transform it into, and we went through this before about the data behavior, how we take it from ERD, entity relationship diagram. We go through a process of join files. We create a star schema. The star schema then enables us to create dimensional analysis, which is your OLAP cubes, which then your pivot tables that allow you, and pivot tables are just measurements, and that allow you to then aggregate and summarize to drive your dashboard. Okay, so this example is that once we get it classified, then we can, in our ERD kind of transactional database, we have to convert that into something that we can analyze through join files, which is technically called denormalizing the data. Then that enables us to then run reports. Machine learning really is just the next step on top of that. That's all that is. And we do a lot of machine learning today without an assistant where you're actually communicating with the assistant. The assistant is known as cognitive services that just sits, it's one another layer on top of data is what it is, cognitive services. That's the voice component. That's when you're talking to Alexa. Hey, Alexa, how's the traffic looking? There's a database of all that information. And right now, it looks like it's a magic trick to most people. Like most people don't understand how Alexa works. They don't get it at all. They don't know that it's a database. It's a voice on top of a database. They don't get that. I try to explain it to them and they just look at me like, what? And that's what I say, don't worry about it. But what's happening is there's still a delay. So Alexa's not anywhere nearly as fast as it's going to be when 5G deploys. As 5G deploys over the next 5 years, it's going to be mind-blowing what we'll be able to do with all this data. I mean, it's just mind-blowing. Like we think right now, Big Brother's watching now. So we're just getting started. Anyway, but what that does is that lends itself to prediction. And prediction is what all these executives are paid for. That's the key. The executives are paid for the clarity of their crystal ball. So let me go back to the very first slide, which is this one, predictive analytics. So as you look at this slide and you hear the word regression, that's the top two items, predictive modeling and optimization. So you had to first get the data. That's the unstructured dimension reduction. You had to categorize it, then classify it. Once it's classified, then you can do statistical analysis. Once you can do statistical analysis, then you do forecasting. That's regression. So actually, I should say the top three: forecasting, predictive modeling, optimization are all components of structured learning, predictive analytics. I don't know if I gave you the answer you were looking for. I mean, I don't know if I gave you a specific project, but if you look down the list, there's a bunch of projects right here. There's all these are projects that you can look at specifically. That's a great question, though. You got any other questions? Did it make sense, what I just said, at all?
Yeah, it was helpful.
Okay.
Sometimes when you see like Cliff, he gave an example of a real project.
Right.
Almost seems like you have to experience it and go through it to understand each step.
Do you have a smartphone?
Yes.
What is it Android or iOS?
iOS.
Okay. Does Siri ever notify you that you should leave to go? Hey, you need to go. You need to go. Like, hey, I see that you're going somewhere, or you're late for work, or you need to get to the airport, or have you ever gotten a notification like that?
No.
No. Okay. No, you've never gotten a notification from the phone at all? Do you get any notifications at all on your phone?
I probably turned them off. So.
Oh, okay. All right. Well, now's the time to turn them back on. Because if you're in this business and you don't know what the machines are doing, then and don't take this the wrong way. As analysts, if you're a business analyst and this is your future, then you need to know what all the devices are doing. Even if it means like, hey, wait a minute, I have to turn on all these notifications. Yeah, because you're going to be asked to write requirements for those. And it helps to kind of know what they're trying to do. So a lot of these notifications, and I understand, trust me, notifications can drive you insane. I'm not telling you got to have them on all the time. But the main one that if you're really interested in seeing an example at your own phone, is if it notifies you that there's traffic, or if you're going somewhere and it says, hey, you should leave now. I noticed that there's traffic. You should go now. That's a very common prediction, regression, machine learning function that you're like, oh, okay. Weather, that's another one. And let me just address that really quickly. These tools, I use weather as a great example because a lot of people are very worried about machine learning taking their jobs, but they're not that smart yet. And the example that I use is weather prediction. And, again, I'm in Florida, and you guys are probably in Florida, and, we get these hurricanes, and you watch the prediction of the hurricanes, and they don't really know until they're happening where they're at. So, and yet we spend more money on weather prediction than any other kind of predictive analytics. Most people don't know that, but the weather is number one. And the reason it's number one is because of the cost of recovery. The insurance industries, and I mean, we're talking billions and billions and billions of dollars that are spent post recovery from a weather event. So much money is put towards weather prediction for that reason, and yet it's not that accurate. So what that tells you is that machine learning is not as accurate as the movies make it out to be. So just keep that in mind as you're moving forward. But companies need that information because that's how the executives are paid. They're paid on this upper level of forecasting. That's really the key. Most executives are paid on forecasting. That's how they're paid. Every quarter, they got to forecast where they're going based on what? Historical data, where they've been. So, and if you're publicly held and you get your forecast wrong, your stock gets hammered. So.
Yeah, Richard, you can add an yet to the end of all that.
Yeah, right. Yeah, exactly. Anybody else?
The Iron Man project that we did was freaking awesome. Nobody realized, they have a lot of sponsors for those races, all the equipment and everything else. So they want to know who's using what. And I mean, we're talking down to the type of tire, type of rim on a bike, the type of, every piece of equipment on a bike, because those are custom bikes that are $15,000 to $25,000.
Wow, that's cool.
So they would take a picture at the end of the race of the participant, which has their number on it, and the bike. And the software was taught to keep a database of exactly every piece on that bike it could recognize.
Brilliant.
And of course, all the sponsors love that because they know who's using what equipment based on, that's the marketing trifecta. Knowing, your money is actually resulting in purchases.
Yeah, absolutely. Absolutely. Knowing what I know, it's funny because I always watch, which movies are close predictors of the future. And I'm still madly in love with Minority Report. I'm still looking at Minority Report, and I still look at Will Smith's iRobot. those two movies to me still are very, very, very close to what's on the way. A lot of very interesting. So very, very interesting. Well, excellent. I appreciate you guys all coming out. If there's no more questions, I'm not in a hurry, but if there's no more questions, we'll call it. Anybody any other questions?
Happy holidays, everybody.
We'll see you guys. Okay, so we're done until January 8th, and then we'll pick it up again in January 8th. So, and then we'll start all over. We'll see where we'll go from there. Hopefully 2021 will be much better than 2020, and eventually we will hope to get back to seeing one another face to face again. So let's hope that that's going to happen soon.
Yeah, maybe May.
Yeah,
if we're realistic.
Let's be honest. Yeah, it may not be till May. Again, if you would like the PDF and you're new, please send me an email to rfrederick.pmp@gmail.com. Again, if you're new, please join us at meetup.com, Tampa Bay IIBA. Cliff's put in the Facebook, the LinkedIn groups. If you're not connected to me on LinkedIn, please send me an invitation. It'd be an honor for me to become a member of your network. If there's any interest in the classes that I teach, just send me a note or whatever. But that's it. We are done. Have a great rest of your day.